My name is Hanan, and I'm doing my presentation about the different applications of propositional logic. It was for my Intro to Logic class, and my professor is Dr. Loengo. We'll start by defining what propositional logic is. I'm going to be using PL for short because I'm not gonna say propositional logic every time I use it. It's basically a Boolean algebra that deals with propositions, and it's also known as sentential logic, propositional calculus, and sentential calculus. Example of PL would be like simplification or modus ponens. What this is saying, basically, if we have P and Q, this little thing means and. I'll like go in depth a little more. We know that we can derive Q or even P by using simplification. For modus ponens, if we have this statement, which is a conditional, we call it, it means if P, then Q, and if we have P, then we can derive Q from it. What Boolean algebra is, it's a branch of mathematics that deals with binary systems, and we have some systems that are binary, for example, PL, electronics, and computers. And here we have examples of what each of them use as their language. For PL, we use truths and falses. Like this is an example of a truth table that for a disjunction, but I wanted you to see what language we use. Is just like it's either true or false. For electronics, we use ons and offs. For example, if this switch is on, the circuit is on, and if it's off, the circuit is off. And for computers, as you might know, we use ones and zeros. And this is like a quick representation of, like an example of what the number, how it gets translated in computer language. What makes something a proposition? A sentence, it's when a sentence is either true or false, it's a proposition. It cannot be ambiguous, it can't be
Hey Hanan, I think your internet connection seems to be breaking up or seems to be lagging a little. Um, Everyone else, is Hanan's stream seem to be lagging for you or
Yeah, I think I thought it was just on my end. I think it's her audio specifically, I think.
okay. Um, let's see. Hanan, can you type in chat see?
Let me see. Okay.
Okay, we can hear you now.
Okay, yeah, okay, maybe it's just when I share my screen, that's what it does. Do you want me to like join from my phone and see if I can share my screen? Or like I don't know if I should like send you my presentation and you can share your screen.
I could do that, yeah.
Okay. Let me 1 second. It's okay if you give me your email, please.
Sure.
Or I can send a link in the chat
Okay,
and maybe you can open it that way.
sure.
That'd be faster. Okay. Can you access it like that?
Yeah, I can see it. I can share it from this end and then you can let me know if to switch slides. Is that okay with you?
Okay. Sounds good. Perfect. Thank you.
No problem.
I was on slide, let me tell you. I was on slide 6.
Okay. Slide 6. Okay. All right. There we
Thank you.
can everyone see that? Just fine?
Yes, it's good. Thank you. All
Okay.
right. I'll
Yeah.
continue.
No worries. In chat, please say in the chat or speak up if Hanan's stream lags again.
Okay. Basically, I was just talking about the simplification rule, the one at the top right. If you can just simplify any statement that is like you have a conjunction of 2 statements, you can simplify either one. You can click next.
Sorry about that.
It's okay. All right, now we can get into the different ways PL is actually used. I decided to talk about 6 of them. So I'm going to be talking about translating English into PL, logical puzzles, Boolean searches, logic/computer circuits, and inference and decision making and law. You can hit next. All right, so first we'll start with translating English into PL. Translating English into PL can help us eliminate ambiguity from the language, and that helps us in decision making and in different systems like mathematics or computer science. An example of how it can be used in kind of like computer science is, let's say we want to translate or we want to have like the system log in a user if they provide the right correct username and password. So the way you would translate it is U would stand for username, P would for password, and L for login a user. So we put the U and P in a conjunction statement together. So we say if U and P, then L. So basically, if you provide the right password and username, then you will be logged into this, like you will be logged in. And another example, I wanted to show how like it can, like the English language can be ambiguous sometimes. If we have an example that says she will come if Jean is there and her grandma is happy, that could be translated in 2 different ways if you're not specific. So the first one, I have J and G then C. that's basically saying if Jean is there and her grandma is happy, then she will come. But the other translation could be that if Jean is there, then she will come and her grandma is happy. So there's like two different ways you can go about this. That's why it's helpful to use PL, because then you're not as ambiguous in when you're talking, or like, I mean, when you're using the system. Like, can you hit next, please? Next is logical puzzles. So any puzzle that requires any reasoning or logic are called logical puzzles, and they can be used for brain exercises, recreational purposes, and for testing a person's reasoning capabilities. An example of that would be a Sudoku. And let's say you want to approach starting to solve a Sudoku. Like, you can go about any box you want, and the logic behind that is like, if the number doesn't exist in the row or the column or the grid, you can, the number you're thinking of is a possibility that can go in that box. And the translation for that would be, if not R and C and G, if that's not true, then you can add the number. And I think you can start to see how the translations work. You can like negate what you don't want to, like, or what's like, here I negated what I don't want there to be, and if that's true, then I can add the number. Can you go next, please? Thank you. Next is Boolean searches. So in Boolean searches, there can be operators used, the same ones as I showed before, like similar ones. And they're also called logical connectives. They can be used to search large data sets, such as like our school provided databases that we can use for our searches. We mainly use and or not for those searches. This is an example of when I searched for my biology research paper. I was searching for how mycorrhizae and fertilizer work together, and I specifically wanted them to be working in synergism. So you can see how you can play around with the operators and the fields, and to either make your research more vague or more precise, and that could be really beneficial. And next, please. Next is logic/computer circuits. The building blocks of any digital system are logical gates or circuits, and they're devices that can be that use the Boolean functions. They're pretty similar to, I mean, they're kind of like similar to the operations we use in PL. Here we have the gates that are or can be used in computer circuits. And I have some of like kind of like a translation towards the bottom, like an and gate would just be a negation of an and operator, and or would be the negation of an or operator. Exclusive or would be like, that's how you translate it into PL, and then the or would be the negation of that. And then, as you can see, the same language is used in both systems. Can you hit next, please? Thank you. Okay, now in an inference and decision making, PL is used in inference and rules, and in the making of inference rules, and they're the ones I showed you earlier, and in decision making. They can be used to then make and validate arguments based on the information that we already have. Example of that, if today's Thursday, then we don't have class. And another sentence would be, we have class today, then we can conclude that today is not Thursday. And in PL, we translate it into if T, then not C. And I added a double negation there so we can see it's the negation of the negation of C. But a double negation doesn't have to be there. We know if we just have something that's not being negated, it's the opposite of something that's being negated. And using the rule modus tollens, we can derive not T based on what we have, the information we have. Can you hit next, please? And in law, PL is used to construct arguments, interpret legal contracts, and in legal reasoning. I wanted to talk about kind of like an example of how it's used in deciding who can vote. So here, it is necessary to be a US citizen in order to vote, but it's not sufficient. And to vote, you have to be a citizen over 18, registered to vote, not a felon, and meet your state's residency requirements. And then you can translate that in PL using two statements. The first sentence that says it is necessary to be a US citizen in order to vote, but it's not sufficient. It's the first line towards the bottom where it says translation. So what that says, if you vote, then we know you're a citizen, and it is not like if you're a citizen, it's not necessary like if you're a citizen, we don't know that you're going to vote. That's basically what it's saying. So that's how we use necessary and sufficient statements in law. And the second sentence, it says, if you vote, then we know you're a citizen, an adult, you're not a felon, and you meet your state's residency requirements. And that's how it's used in law. Can you hit next? Okay. Other kinds of logic can be used as an extension to PL or as a limit. And examples of those would be predicate logic or fuzzy logic. Can you hit next, please? Predicate logic can also be called first order logic. It's an extension of PL because it uses the same language, but it also adds variables, predicates, and quantifiers. And an example of that is it's called piano axioms, and it's basically the foundation of mathematics. And one way that could be used is, as you can see in the picture on the bottom right, and it just shows you how piano axioms, like how you translate the natural numbers into piano axioms, and the opposite, or like the opposite A, the upside down A is read for all X, and then whatever like is inside that parentheses, it's like it goes for whatever is inside that. Can you hit next, please? And I think this is my last slide. Fuzzy logic can be a limit to PL because it can include values that can be partially false and partially true at the same time. Like it's not a hard true or hard false like in PL. And an example would be temperature. And then we have a comparison of Boolean logic versus fuzzy logic. Like in Boolean logic, if you ask, or even in PL, if you ask, is it hot? It either has to be a yes or a no, or true or false. But in fuzzy logic, you can include intermediate answers. You can say it's a little hot, or it's very hot, or something in between. And that's basically it. And then if you hit the next slide, I think, yeah, that's my presentation. Thank you.
Awesome presentation, Han. This is predicate logic I didn't know it had so many applications. But
Yes, I didn't know either. That's kind of why I did this presentation.
all right, everyone. So that was Hanan's presentation. Thank you. We'll open this up to a 5-minute Q&A. So if you have any questions, speak up. Yeah. Sorry. Okay, I kind of wanted to ask Hanan because so I've
Yeah.
taken Dr. Luengo's predicate logic class before. And it still marvels me to see how many applications, but after going through this course and just living through life, have you seen it pop up in your head? You just go, Hey, propositional logic.
I was talking to Dr. Luengo the other day about how she had it, or like her and her husband were talking about this, and then he used I used it as an example in my slides about I like kind of modified it, but he was talking about how he thought today, like the day was Thursday, but since she was teaching, it was like, oh, today is not Thursday, and it's used modest Stallings, and then I included it in my slides. In my personal life, I haven't like encountered anything like that, like where I thought, oh, that's PL right there. But I've definitely seen other students use PL in like their computer science classes. And I'm like, oh, we learn about that. And it's kind of like cool to sometimes understand what they're doing.
So, do we have any other questions from our audience?
I don't have a question, but I have a comment. Hanan, you've done a great job.
Thank you so much.
Yeah, thank you for sharing with everybody the applications of propositional logic. And I know that maybe people here are not so interested, but Hanan also gave the same presentation to the class. And I think that all the students got a lot out of it, knowing that what we've been doing actually has a purpose other than just being fun, which I
Yeah.
believe it is.
Yes. No, thank you a lot for helping me too. I appreciate it.
All right, no other questions? Got
All
it.
right.
But yeah,
Okay.
Hanan, thank you for your presentation. Dr.
you.
Lingo, thank you for joining us.